You don't have to hand it in yet. You can take Amir's back to him as well. He might want it. Okay. Now, I'm going to stop babying you guys. I'm going to stop saying take out a piece of paper because as grade 11 students, you should be prepared with all of your materials. So I'm just going to start writing and I'll assume that you can get out a piece of paper and sort yourselves on that. Does that sound reasonable enough? Yes? Okay. Draw a particle diagram showing a saturated solution of calcium hydroxide. All right. Now, this relates back to the concept of saturated and unsaturated. How can we tell if we have a saturated solution? Chat with your neighbor about that. How can you tell if your solution is saturated? Anyone want to give it a try? Give me some ideas. Yes?
Saturated solution is where the max amount of solute contains, which means that it can't crystallize anymore. It can't recrystallize anymore.
Well, it actually can recrystallize. So I'm glad that we're getting this out because it actually does recrystallize.
Okay, well, essentially what it means is that you can't dissolve any more solute into it.
You cannot dissolve any more solute into it because it is full. How do you know that you've gotten to that point?
Some particles that lose their bond.
Yeah, there is some solid left over. So despite stirring, you have added enough solid that some will not dissolve. Okay, you've added enough solute. Okay, so you've added enough solid that some will not dissolve. Now, why is it not dissolving anymore? What we're going to do is we're going to draw a solution showing saturated calcium hydroxide. So we have, in our little beaker here, CaOH2 solid. I'm just going to put it in one lump at the bottom. Okay, I know it's not in one lump, but we're going to make it easy that way. And what's going to happen is, if it is saturated, well, first of all, CaOH OH2, when it dissolves, what do we get? What happens to the ions? They separate from one another, okay? So we end up with Ca2 plus, and we end up with two separate hydroxide ions. And what state are those in?
Unstable.
Solid, liquid, gas, or aqueous?
Oh, they're still in, oh,
Are they solid?
oh, no,
No, they're dissolved.
no.
So our choices of state are solid, liquid, gas, and
Aqueous.
aqueous. These are aqueous because aqueous means
Oh,
dissolved in water. Okay, so we have Ca2 plus aqueous, and we have 2OH minus aqueous. This is going to be unsaturated. Okay, so we have lots of room. What's going to happen is that we're going to get Ca2 plus ions coming off, and we will also get an OH and an OH. Yes? And at this point, this is at the very start, there is nothing in there to recrystallize yet. With me? Okay. Now later, we are still unsaturated. So we already have some Ca2 plus and some OH floating around. And we have some Ca2 plus and some OH floating around. But we're still going to have new stuff coming off. Ca2 plus, OH, OH. Ca2 plus, OH, OH. With me? Okay, so that comes off and dissolves. And that comes off and dissolves. But what's going to start to happen is because there were already calcium hydroxides in there, we're also going to get the hydroxide and the hydroxide and the calcium recrystallizing. So these guys here, these are dissolving. These guys here, they are recrystallizing. Do we have more dissolving, or do we have more recrystallizing?
Oh, sorry, more dissolving.
More dissolving, right? Because we are still unsaturated. we have more dissolving and less recrystallizing. We're still unsaturated. It is not yet full.
Saturated would be less dissolving form. No? Okay, but I have a question. about
Yes.
So, the reason why do some crystallize, like, salt, for example, once you put a little bit of water, it dissolves completely? Is it because the attraction to water is greater than calcium hydroxide, and calcium hydroxide attracted to water? So that's why some
Part of the reason. Yeah.
crystallize more than crystallize.
Yeah. Some in grade 12, we'll learn that this is an equilibrium. Things that go backwards and forwards are called equilibria, right? The dissolving is one way, the recrystallizing is backwards.
Oh,
Okay. And so when the rates of dissolving and recrystallizing are equal, that's when you are saturated.
oh.
That's when you are at equilibrium, when the two rates are equal. So it is as full as it's going to get. You have the same number of guests checking into the hotel as checking out of the hotel because every single room in the hotel is full. Yeah? Right now, there are empty rooms in this hotel. So more people check in than people check in faster than they check out. So that is unsaturated. Okay, now we're going to move to saturated. And I'm going to have to make it bigger because there's not enough room in that little thing. So I'm going to make this one bigger. Bigger beaker. Bigger beaker. Ah. Okay. So out comes our calcium and our two hydroxides. Out comes our calcium and our two hydroxides. But we already had some calcium dissolved and hydroxide. And we already had some calcium and some hydroxide and some hydroxide. And then there's just random calcium hydroxides floating around in your solution. That are maybe not recrystallizing right now. What do you notice about the rate of dissolving compared with the rate of recrystallization? Chat with your partner about that. Recrystallization is in red. Dissolving is in black. They are equal, right? There's two dissolving, there's two recrystallizing. When the rate of dissolving is equal to the rate of recrystallization, what will happen to the concentration of calcium, say? Will the concentration of calcium change or will it stay the same? It will stay the same because every time you put an extra one into solution, another one recrystallizes out of solution. So therefore, the concentration of ions stays the same. Yes.
So let's assume this beaker is 150 milliliters of
Yep.
water and the thing is saturated. If we add 50 milliliters, it'll become unsaturated.
Of water, yes, it will become unsaturated.
Yeah, and it can get good puffs all over, that.
You would have to, yeah, you would just have to stir and wait for it to, come to a position where no more is dissolving.
Right.
Yeah. Yeah? Okay, so how are we going to draw this without it looking like a big, horrible mess? Yes? All you need to do is, what I would do is, this is saturated now. It's full. And if it's full, the concentration of the ion stays the same. Now remember, up here, we had more dissolving and less recrystallizing. What happens to the concentration of the ions in our unsaturated solution? If we're dissolving more and we have less recrystallization, what happens to the concentration of the ions? Does it stay the same? Does it go up? Does it go down? Chat with your neighbor about that. In our unsaturated solution,
Okay, so I have like the
CAs and OHs.
bonding.
The concentration, how many there are in the, how many? Are we ending up with more Ca2 pluses floating around? Less Ca2 pluses floating around, or the same? I am making 2 dissolved calciums. I am using up 1 dissolved calcium. This is unsaturated. Okay, we're not in our saturated diagram, we are in our unsaturated diagram. There are 2 times as many dissolvings going on as recrystallizings. If I am making more free-floating calcium than I am using up, what happens to the amount of free-floating calcium? It increases, right? So the concentration of the ions increases. You're making more Ca2 plus aqueous, and you're using up less Ca2 plus. It's becoming solid. Now, like I said, you're not going to have to draw like this whole thing on your lab. This is crazy. Yes, we got like so many ions floating around. All you need to do for your lab, let's do that part. Now that we're kind of getting the hang of it, what we're going to do is we're going to draw our beaker for the lab. Now, let's say in my solution, I draw 3 calcium ions. How many OHs should I have? Remember we have Ca, oh, what did I do wrong here? What is wrong with my formula? I'm so embarrassed. This is terrible. What did I do? The 2 should be outside the brackets. Holy moly. I'm like, what on earth is that? That's some kind of nut house thing. I don't know. Anyway, all right, that looks better now. How many hydroxides should I have in my solution if I have 3 calcium ions? I should have 6 because it is a 2-to-1 ratio. I have 2 hydroxides. Okay, so my hydroxides, I'm going to draw 1, 2, 3, 4, 5, 6. And all I'm going to do is I'm going to draw an upward arrow the same size as my downward arrow. And I'm going to say this is dissolving. And I'm going to say this is recrystallizing. And that, my friends, is a saturated solution when the rate of dissolving and the rate of recrystallization are the same. The dissolving rate and the recrystallizing rate are the same.
I think I intend concentration on like
Concentration is how many particles there are per unit volume.
right, but shouldn't it stay the same because
If I am making more ions and taking them away, then I am taking away. It's dissolved ions, not solid ions, dissolved ions. Ah, okay. Yeah. So the dissolved ions, we never measure concentration of a solid because you can't have concentration of a solid,
right, okay.
right? Because we're always looking at how much is dissolved in the solution. Does that make sense? Yeah. Okay. Cool. So that right there, basically this is the answer to number 7. Okay? Now, what was I going to ask? If you guys, did you want to spend like 5 minutes putting together your lab and handing it in or whatever? Yeah? And if you have finished your lab and you've handed it in, then you can be working on reviewing all of 2.4 for your quiz tomorrow. Okay, so I'll give you guys, 10 minutes or so? So till 5 after 1?
Do I miss any henna?
You're all done? Perfect. Put in there yeah, perfect. Yes, and you're going to staple that on there. Don't forget to staple on your drawings of your safety stuff, okay? Yes. So if you have your drawings of your safety stuff, make sure you staple that on. Sorry, we'll grab that back for you. Is that yours? There's a stapler right there. Yesterday there were no new handouts.
Oh.
Did you check on Teams with the video and everything?
Not yet.
Not yet, but you will later?
Yeah.
Okay, cool.
Because I see they have lab henna or something.
Yeah, were you here for the lab?
Report?
Were you here when we did the lab?
Is that a lab? I don't think I am. I wasn't here yesterday.
No, the lab was last week.
Like Friday?
Do you remember were you here when we did the Bunsen burners?
Oh, no.
And we put the stuff in and we started?
No.
No. Okay, so I'm going to get you a copy of the lab. You can get the results from someone and then you can fill it out. Thank you. Hi. I need to print something out for him, and I need to answer your question.
Dimensional analysis.
Yes.
What? She's home.
Dimensional analysis request.
What?
No metric. B. Okay. Here we go. Let's grab this. Let's grab this. All right. I need to grab this. Just give 1 second. Sorry. Yes?
Just staple the features.
Yeah. Yeah. So if you've got your just the safety
Oh,
stuff.
that one is.
Yeah.
Oh,
Yeah.
just seal it.
Yeah. Labs. Pairing a solution. Yeah.
Question for number 3. The only part I could really see it is here, but I still don't know why.
Okay. If things are more soluble, they will be more easily dissolved. So sodium chloride must be more soluble, and CaOH2 must be less soluble. And that's all there is to it. Okay?
Where's the washroom ticket thing?
It is out.
Okay.
Yes.
Do you think there's time today to quiz the most recent quiz that we did?
Sure, if you want to. I mean, we may have a lesson while you're doing it, but if you're okay with that, up to you.
I'll try to focus on the lesson.
Okay. There you go. Print. Copies 2. Flash is back. If someone was wanting to go to the washroom.
What flash?
Lab, staple. John?
I started when I just turned 14. I didn't do it much at all. So I was young, but I don't want to take it. I didn't know the markets on the stuff that shit. All of the chips and like you can get your side of that. Yeah. Pretty sure I know how to do it.
We're adding and subtracting for example, this for you.
Okay, so what you're going to want to do is you are going to find someone and copy their lab results, and then you will answer the questions.
What about the Bunsen burner?
What about the Bunsen burner? Don't worry about it right now. Okay, yeah. Which one? The last one, and you're okay missing part of a lesson to do that? Okay.
Can I borrow scissors?
You can borrow scissors.
Thank you.
There you go. Okay.
This one.
You okay?
I'm just trying to think. Yeah.
Yeah, I think so.
Perfect. There you go. Thank you. Thank you. Hi.
I don't know where my drawing is. I think I just got.
Oh, that's okay. Just hand it in. If you find it at home, bring it in tomorrow and staple it, and I'll let you staple it on. It's all good. Yeah. Okay.
So the other part is the and have accepted, right?
You can do either or both. Okay?
Order analysis.
I know, right?
Oh my God, right?
Anyone still working on their lab? Anyone still working on their lab? No. Okay. What's that?
I am, but I'm reading.
Oh, okay. So you're good. So we won't worry about it. All right.
Spent work like this. He said he's gonna keep that volunteering. Sorry.
All right, friends. We are on page 83. 83.
There are more.
Yeah. Now, that being said, if you are still working on your lab, you can hand it in tomorrow. It's not the end of the earth. It's fine. Okay? So we are going to be looking at density, the concept of density. And we will also be using dimensional analysis. What is dimensional analysis? Dimensional analysis is just unit conversion. And unit conversion is where you have your unknown is equal to your initial quantity times a conversion factor. And I'm going to put the conversion over the factor because that's how we usually write it. It's one thing over the other. Yes? So hopefully by this time in your lives, you've dealt with the concept of density before. Okay? Density is equal to the mass over the volume. Density is literally the mass contained in a given volume. All right? What's mass? Mass is the quantity of matter. How much stuff is in it? Okay? Volume is the amount of space. So how much stuff is there in the amount of space occupied by this stapler? It feels fairly heavy to me, and that's probably because there is a lot of metal, and metals are fairly dense. Yes? On the other hand, no, okay. On the other hand, this eraser here, right? It's very light for its size. It's not that different in size from the stapler, but the stapler is much heavier. Which one is more dense? The stapler is more dense. So this has more matter, more protons and neutrons packed into the same amount of space. Yes.
It's the same thing, like nothing like that eraser thing will probably float into the water.
Yes, exactly. So if I put this in water, yeah, this is going to float because it is less dense than water. This is going to sink because it is more dense than water. If you had something that was the same density as water, it would actually just hang out wherever you put it in the water. So if you put it on the top, it would just sit there. If you moved it down to the middle, it would just sit there. If you put it at the bottom, yeah.
Really, I can see that. But
Okay.
Same thing with like pins and stuff. Like an apple would float.
An apple will float because it's less dense. Pins will sink because they are more dense. Okay? And it doesn't matter the mass. I mean, a pin is not very heavy, but it is more dense than the water, so it will sink. So how do we calculate the density of something? All we do is we take its mass and we divide by its volume. Can you guys stop talking? Okay. Okay. So we have density is mass divided by volume. So if you are solving for density, you need to write the formula. This is to get full credit. Write the formula. So you will get a check mark for this. So that's 1 mark. You need to plug in the values from the question. So in this case, we are told that an iron bar has a mass of 19,600 grams, and it has a volume of 2.50 liters. So we plug in, instead of mass, we write down the actual mass with the unit, and then we plug in the volume with the unit. So that's going to be worth 1 mark. You'll only get a half if you don't put in your units. Okay. And then you throw that into your calculator and you get, what do I get when I actually do that? Let's see what my original calculator value is. 19,600 divided by 2.5 equals, and I get 7840. So you could either write it, I mean, it has 3 sig figs. We have 3 sig figs here and 3 sig figs here. So our answer should have 3 sig figs. 7840. And your unit, you can either write it like this. This is the only time when you're writing your final answer, you can use that little slash rather than one over the other, or you can write it as grams over liters and just always be doing it that way, and then you're consistent. Yes? Okay, and I would put a box around my final answer because boxing your final answer is always a good idea. So you would get 1, 2, 3 marks for this question, right? Writing the formula, plugging in the values with units, and then having your correct answer to correct sig figs with your units. Oh, look, I boxed my answer there. You don't have to write it in 3 steps. you would just do it in one line. You would write your formula. You would plug everything in, and then you would write your answer, and that would be out of 3. 3 out of 3. Yay! Okay. Now, we are going to use density as a conversion factor, and in fact, you have already done this, haven't you? Have you already done this? Maybe on your quiz? Okay, so we have, if mercury has a density of 13,600 grams per liter, what is the volume in milliliters that is occupied by 425 grams? Now, you may have noticed on your quiz that you got back last day, for many of you, I went like this, and I went like this, and I went like this. Why did I do that? I did that because this is your unknown. How do you know this is your unknown? Because we don't know what it is. It says what? It's got the question word. That's our unknown. What volume is occupied by 425 grams? Those two things are connected. Yes? And the initial is connected to the unknown. Okay? So if you're solving these kind of problems, you can say, oh, what volume is, oh, there's my initial, it's connected. Now, I want volume in milliliters, and I have grams per liter. So I'm also going to have to convert between milliliters and liters. Also, don't forget, when I'm given this slash notation, I don't want to write it like that. Oh, no, okay. I don't want to write it like that. I want to write it like this. Yes? One over the other. So let's start with our initial, which is 425 grams. That means our grams have to go on the bottom and our liters have to go on the top. And we get that from the question. We get our numbers from the question. Grams cancel with grams. And then I want the volume in milliliters, not liters. So I have to cancel the liter. Remember, the 1 goes with the prefix. Oh, there we are. And our power of 10 goes with the regular unit. And we end up with 31.3 milliliters. Is good? Okay. You have another option using the density formula to find the answer. However, I will tell you this method is less work. Okay? Because if you're going to use the density formula, you, number one, have to write density equals mass over volume. You have to solve for V. So you get a mark for that. And that requires you to solve it correctly. So if you're good at algebra, that should be fine, no problem. Okay, there's a lot of blah, blah, blah. And then at that point, then you start substituting things in. I don't know why I've got so many words on this page. I'm very, very sorry. There's so many words on this page that don't need to be there. Okay, so then we substitute in. What is my mass? It is 425 grams. What is my density? It is 13,600 grams per liter. Now you would want to show that those cancel out. Okay, now what the heck is happening here? My grams cancel out. Oh, or I can say I have grams over grams per liter. which is the same as multiplying by liters over grams, which means that I get liters. And if you don't feel comfortable about the fact that this gives you liters, then you should not choose this method. Okay? But it is a method that is open to you if you want to. I'm not going to stop you from doing it, but just make sure you show your units, you show the cancellation, and you're all good. All right? And like I said, I don't know why there's so many words on this page. I'm very sorry about that. So this is what it would look like. You would say density equals mass over volume. You would write your original formula. You would then write it like that. You would show that, and then you would convert it into milliliters. Okay? Finding the mass. Here we are given density. So this is now on page 85. We are now given the density. Find the mass of the sample of silver that occupies 965 centimeters cubed of space. Now, what do you remember about centimeters cubed? 1 centimeter cubed equals 1 milliliter. And you don't need to do a conversion on that. You can do a simple substitution. Yes? Okay, so I'm going to say I don't want that unless it is given in centimeters cubed, so I don't even need to worry. That's fine. I am starting with, I want to find the mass of a sample that occupies, if that's my unknown, then who is my initial? The thing that is connected. The unknown is connected to the initial. Okay? So we can do it this way. We can say, I don't know how many grams. How many grams? I start with 965 centimeters cubed. I need centimeters cubed on the bottom. I am given that there are 10.5 grams per centimeter cubed. Centimeters cubed cancel out, and that gives me grams. I only have 3 sig figs here, 3 sig figs here. So that gives us 3 sig figs here. Or you could write it as 1.01 times 10 to the 4, which is kind of nice. Okay? You can use the density formula. You would say density is equal to mass over volume. And then you would solve for mass. Mass is equal to volume times density. Volume times density. Oh, look, it works out exactly the same. We good?
I was just wondering if you would be mad at me.
You can take the flash right now. It's okay. And then we end up with grams. And then we're done. Okay, so we have some exercises here. Ooh, we're going to omit B, 2B, and we're going to omit, actually, we're going to omit all of question 2. Okay? So there we go. So you can work right now on pages 86 and 87. And if you're finding those too easy, you can try some of the challenge questions on page 88. On the other hand, if you're like, I really just want to practice for my quiz tomorrow, then you could do the quiz practice stuff in section 2.4.
is the.
Yeah. That's the dimensional analysis one, right? The unit conversion? Yeah. Form B. No? Just handing that in? Good, good, good.